We know that the purpose of the particle model of matter is to help us to understand matter and its properties and behavior. And the first way that it helps us to do that is by explaining various properties of the various phases that matter can take. So we are going to be speaking about the three major phases, those being solids, liquids, and gases. And we are going to look at how the way in which those particles are arranged affects the properties of that substance. So we are going to start by looking at how those particles are actually arranged inside solids, liquids, and gases. And we start out in solids, where we know that the particles are very tightly packed, meaning they are close together and arranged in an organized pattern, meaning that they form a structure that is easy to follow and there's a pattern there. It is often also referred to as a lattice structure. As you can see, there is no space or very little space in between these particles. As a result of that, the only movement that is possible for each of these particles is a small vibration, either left or right or up or down, but for the most part, this particle will remain in its fixed position and just vibrate slowly left and right or up and down. As we can see, in order for something like this to be possible, the forces of attraction between molecules must be incredibly strong. Those strong forces of attraction are what keep them neatly packed and tightly packed and close together in that organized arrangement. Then if we look at liquids, we know that liquids are slightly more free in how they move. So what we find is that the pattern that liquids have is completely or far more random, in that the particles have slightly bigger spaces between them. This allows them to move, but what they also have is no definitive arrangement. So what we can see here is they are still close together, but there is no fixed pattern here. What this allows is that these particles are able to move over each other, and they can move much faster than in solids. They can move over each other, which allows them almost complete freedom to move wherever they want, which explains why liquids are able to fill the container that they are in and why we can pour liquid, because we're allowing those particles to move over each other and move freely. As you can imagine, in order for these substances or for this to be possible, we know that liquids tend to prefer to stick together. So there are still reasonably strong forces of attraction, but they are not as strong as the forces of attraction in solids. And finally we get to gases, where in gases the particles are so far apart that they are almost completely unrelated to each other. There is no pattern, there is nothing that is keeping them together. As a result, they are able to move very fast in whichever direction they want, and that movement is completely random. It is not governed by what the other nearby particles are doing. And then finally, because these particles are so far apart, there's almost no, or we say negligible, forces that exist between them. From this, you can also start to infer a number of other properties. We can see that liquid would be something that is able to flow and fill the container that it is in. We can see that gases are going to be something that have a very low density, which is why gases are not very heavy, because the particles are so far apart. And we can also slowly start to see how it would be possible to change from a solid to a liquid, because what you would need to do is you would need to start to break those forces in between the atoms or molecules.